Right. Another way we can sort of graphically and intuitively and visually group our data together or display our data is called a stem and leaf plot, sometimes a stem and leaf display, sometimes just a stem plot. I don't know why they have so many different names for some of these things, but I prefer to call it stem and leaf because to me that describes what it is. Suppose I got some data here, just again, meaningless data, and I want to organize it a little more graphically. I'm going to take a vertical line here, and sometimes people label these, but we're going to have the stem on the left and we're going to have the leaves on the right. And the stem is going to be the first digit of each of the numbers. So we're going to have to think of this as 05, 04, in the other order, 08, 08, 12, 13, etc. So we get some that start with 0, some that start with 1, some that start with 2, 3, and then we've got one that starts with a 5. Again, just like the dot plot, we need to show that there's a gap there, so we can't skip over the 4 and just put everything close together. We need to have all of our stems accounted for, even if none of them are represented in the data. So we need a 4 here, even though there's nothing that starts with a 4. Apparently, it's traditional to have these in ascending order, so your bigger numbers will be on the bottom as opposed to the top. I disagree with that. I really prefer it the other way, but every example I find is like this, so we'll go with this. All right, so in order, going out from the stem, from least to greatest. So 04 will look like that. 05 will look like that. 08, and of course, since we have 2 of them, we need 2 of them in our plot. So we have a stem with 4 leaves on it representing those 4 numbers. Then we've got 1, 2, 1, 3, 1, 9, and 1, 9. A 20, a 26, a 35, a 37. No 40s. Don't put a 0 there to show none because then it'll look like a 40. And then we put a 0 on there for 50. And again, we can see that we have a gap that shows an outlier. That's why we need to make sure our stems are all represented, because if we left that 4 out, we would not see that space. All right, so that's it. And again, like with the dot plot, if you can draw one of these, then you can read one. You know that this represents the number 4, that's 5, that's 8, that's 8. And you could reconstruct this list of numbers from this plot, which is maybe for a small set of numbers like this, not really a savings, and it doesn't really show us much that we can't see. But imagine if we had 20 or 30, 40, 50 numbers here, we would be able to look at this and say, hey, these numbers are clustered right there. There's not very many of them. There's a few gaps, all that kind of thing that you might notice. Now, I do want to do a slight variation on this, and we're only at 3 minutes, so got time to do this. Suppose I got some grades here. Right? I got some grades in the 60s, 70s, 80s, and 90s, which would be fairly typical for any given test. If I were to do the stem and leaf plot, I get my 65, my 72, my 73, my 74, my 74, 86, 87, 87, 89, and then 91, 92, 92, 92. And that looks fine, okay? And it looks like my data is all just nicely clustered there. But if we look at this a slightly different way, let's take a 6 and then 2 7s, 2 8s, and 2 9s. Okay, so let's set our stems up like that. And let's say this 6 is for 60 through 64. 0, 1, 2, 3, and 4. That's 5 grades. And then, I'm sorry, the 6 won't be. The 6 will be for 5 through 9. So 65, 66, 67, 68, 69. Then the 7 will be from 70 up to 74, and then from 75 up to 79. Okay, so 70 through 74 is half of the 70s, right? 70, 71, 72, 73, 74, that's 5. And then 5, 6, 7, 8, 9 gives us the other 5. So we're splitting that letter grade essentially into 2 equal categories. If we look at what we get here, we get 75, or 65 rather, for our first one, 72, 73, 74, 74. And then 86, this one goes 80 through 84. This one starts 85. It's like 86, 87, 87, 89, and then 91, 92, 92. So our first one made it look like our data was really consistent, like all of our grades were just one big happy cluster there. But if we break it up a little differently, we see that we had a cluster of grades here and then we had a cluster of grades there, which as a teacher tells you something about either your class or about the test you gave, that you had students that did right there, and that's only 6 points apart between all of those. So they essentially all get the same grade, and these guys all essentially get the same grade too. Whereas here it looks like everybody was in a nice evened out distribution. So you can play around with the stem and on the stem and leaf plots to see different dynamics like that later.